Okay, few of you asked me about mechatronics, so I'm just gonna do this quick video to just discuss this field. So from my personal experience, I didn't study this field, but I worked slightly in it, and I worked with a lot of people that actually have this degree, and I was really impressed. They're very smart and also very hands-on. You don't always get this with engineering because in many cases, if you have a bachelor's degree, you just do a lot of um, theoretical work courses, and then if you want to do hands-on, you have to get a diploma or so. So anyway, one of the universities actually that have a dedicated mechatronics engineering is Waterloo. In most cases, actually, you will find mechatronics as an option in third or fourth year in mechanical engineering, almost always. But some universities have this as a separate engineering discipline, which is really good. So the first thing to know is the applications, especially these days. The need for mechatronics engineers is due to the fact that new technologies such as autonomous vehicles, drones, 3D printers, all these things, they actually require mechatronics engineers, and we will see why. Okay, um, so keep in mind about the applications, and obviously the biggest application is robotics. Typically, robotics previously it was a sub-discipline either in electrical or mechanical engineering, but mechatronics robotics play a huge part. Okay, so if you want to know about what kind of fields actually are involved, let's just if we scroll down, you can take a look over here. So it tells you typically you will have a mix of engineering and math normally in first year, and then when you go into third and fourth year, you will actually study dedicated courses for mechatronics engineering, and we will see some of those. Okay, so in summary, just about if we're talking about the academic side, it's mechatronics is a mixture of machines, electronics, machine learning, and software. Machine learning, it's these days, but previously people that used to study it, it's real electronics, machines. Okay, and we will see. I'll show you an example of a curriculum and software as well. So you have to know how to program, you have to know how to design electronic circuits, and you have to know about how machines work. Okay, and very crucial thing that I touched upon at the beginning is the fact that you will need and you will use hands-on experience. So all this maker lab, make lab, all these things where you're not only designing and looking at the theory, the math, and the physics behind things, you'll also actually doing some hands-on work. So let's take a look at what kind of courses are involved in here. Okay, because keep in mind I'm talking about this is a program for mechatronics engineer, meaning from the beginning, meaning from first year. It's not something that you do in third and then fourth year. So you will have a mechatronics engineering course. Okay, and typically whether you're doing mechatronics engineering as a separate discipline or from third and fourth year, typically you'll need chemistry, algebra, calculus. This is almost common in all of engineering courses. Structure and properties of materials. So this is crucial because we're building stuff, correct? So you have to know how to do this. Okay, you have to know how to select the material. Are you selecting steel, plastics, composites, polymers, all these things? Um, Statics. Okay, so this is not statistics. This is statics. This is and in some cases they call them vector mechanics. I believe they're related. So this is the study of structures. Okay, and then circuits, electric circuits. So this is it's typically an electrical engineering course, and algorithms and data structures. So this is when we actually talk about programming and software engineering. Okay, and then when you go into the upper years, microprocessors. Okay, so this is again electrical engineering. So this is when you're doing the circuits, like how to program, how to control something. Okay, control engineering is very, very crucial in mechatronics. Sensors, instrumentation, same thing, because basically when we're talking about mechatronics, and I mentioned robots earlier, you're having an object, could be a car, could be a drone, could be anything, and you're collecting data to be able to do control engineering. How do you collect the data? With sensors and instrumentation. Okay. And then over here we have machine design, electromechanical machine design. Okay. This is very specific but very good. So the people that I worked with, they used to design machines. So this is something that they study. And obviously over here we have autonomous mobile robots. So this is just some examples about the stuff that you will have to study. So another university that is well known in the field is Carnegie Mellon in Pittsburgh, in the US. And they normally, I believe, they have mechatronics as a discipline within mechanical, so it's different from Waterloo, the one that I spoke about, which is in Canada. So this, just gives you, if you want to know more about some courses, okay, like what do they actually, if we're talking about a course in mechatronic, not in like microprocessors or circuits or something like this. So normally you will learn the typical stuff: control, electronics, mechanical mechanisms, and functional systems. Sorry, to achieve functional systems. So basically what you're doing is you're learning all this to build systems. Okay. And one thing that I wanted to actually show you is earlier I emphasized the hands-on dimension in mechatronic engineering. So a lot of courses will have lab projects. Okay. So you will have a team, you will build things. Okay. And then if we go here, this is very crucial. So you'll have the lectures, okay, and again, if we go back, okay, I will keep emphasizing what kind of courses you will need. Okay, you will need, obviously, we spoke about the previous stuff, but let's go into more detail. Okay, so design methodologies, you will need to take a course in how to design. Okay, so this is not a course that any engineer takes. System modeling, same thing. How to model a system, how to take a physical system and then model it using typically physics, chemistry, all these things. How to turn it from physical into math, into something that you can program, into something that you can control. Okay, sensors and output interfacing. So this is also crucial. Remember, I told you all the data that you're gathering, because to control something, you need to be able to have live data. Imagine you're controlling a drone or something like this. You'll need data. So a lot of these things come from sensors. Okay, once you have the data, you have to control. Either you're controlling specific systems or microcontrollers as well. Okay, so these are some of the things that you need. Another very, very good university, probably the best in the world in this field, is Stanford. Okay, so all those links that I'm having, I'm gonna post them as well. So let's look at this course as well. So this is an online course that anyone can take. I believe it's a graduate course, meaning it's master's or PhD. And normally this is a higher level one, because typically, like I said, mechatronics is something that people study third or fourth year or even in masters. Okay, so what does this course discuss? So again, you will have controllers, electronics, all these things, but this is something else. So this is more about electronics. Okay, so this is all the converters, op amps, filters, power devices, all these things are electronics. If you take an electronics course, you will learn what all these things are. Software design, like I said, programming is very, very crucial. Okay, you'll have to program. Whether you these days, some people use Python. In the past there was like an assembly language, so it doesn't matter. Okay, so you can take a look at this one as well. Another one, well, I said Stanford is one of the best. I would say MIT is the best overall in almost everything. They also have a mechatronics course. This one is a little bit old, but the basics are still there. And the good thing is you can take a look at the syllabus. So this is even going into more details, right? A lot of stuff that you see, a lot of the marks that they have, it is almost all about labs. So these two labs were 25, that's 50, right? 75 and 25% for the final project, meaning you don't even have tests or something like this. It's all labs, okay? And you can read more about this. LabVIEW used to be, I used it in the past. I don't think might be used, but there are other stuff. This is something. Remember, I talked about system modeling and simulation. So rather than build something physical, you can use something in LabVIEW, and it will give you almost the same response as something physical. Then you can take a look at control systems. This is a very unique discipline within, typically it's within electrical or systems engineering, but in mechatronics it is very crucial. You can even, for this one, click learn more about the course. The good thing is they have the syllabus, the textbook, tells you about the assignments, all these things, the readings. Okay, if you wanna get ahead, it's good. Even if you're not, going to this school, but this is MIT, the best university in the world. So stuff that they teach, it is very very likely that other universities are teaching as well, and they have some PDFs. You can take a look at what what kind of problems they're actually asking students to do. Okay, the final thing that I wanted to discuss in this video or series of videos is OpenBot. So this is when I spoke earlier and I said that hands-on is very, very crucial in mechatronics, much more than any other engineering discipline. So this is an open source system that you can design. So basically, it's a combination of a 3D printed vehicle, and that can be controlled with a smartphone. So I really urge you. So this is something that um, that you can do yourself. You don't need to do it in a school lab, but a lot of the labs that you will be doing will be something very very similar. So basically, with this one, let me just turn on the volume. Basically, what they're doing is they are using a phone to act like a controller, like a processor. Okay, and it has many applications. You see here, it is actually, this is called um, either detecting object recognition, same thing. And the good thing is, if I can just go back a little bit, is you can do this using a smartphone, because in the past, doing the control and the microprocessors, you needed something else. Those of you that are familiar with the field, there is I forgot the name. I think it's called Pi, and then there is Arduino as well. Stuff that you can actually program to be able to do functions. Okay, these days you can do it with a phone, because your phone has a lot of things. It has the sensors, all these things. Okay, so you can watch this video, and it actually tells you how this is done. You just need your phone. You can purchase the little vehicle itself. Okay, like a robot almost, or you can build it yourself with a 3D printer. Okay, so I'll post the link as well. So this is really really a fun kind of exercise, and I've seen Canada actually. There was a university where I used to work, and they used to have summer camps for kids, and they used to teach them these things, and all the kids would be very happy. And it's a quick introduction into uh, different fields of engineering. If we can go back a little bit here, I spoke about programming. There is a Python program that you do. There is AI as well over here. You're dealing with a lot of data. This is the 3D printed portion. Okay, so if you have access to a 3D printer, depends where you live. In some countries, every library has a 3D printer that you can go and print for a fee. So you see over here, this is an example of a robot that holds coffee. So it does it delivers coffee to a person. So it tells it which person exactly. So it will go detect or it will say which room, and then you can think of different applications in healthcare. For example, during COVID in China, they used to do something like this, where there was a robot that would deliver either PPEs, masks to patients. So it has a lot of applications. So if you have the means and if you have the access, I would seriously urge you to do this in your spare time, and this will be something that will give you a lot of ideas about what to do in the future. Okay, good luck.